That goes just for this model or for all?
Any.
This applies to most bass. This definitely applies to the 21, the 51, 61, and 6300. These are all the same exact weight. 2500 is the same setup, only this part down here is on top. It's upside down. But it works the same way. And the 7100 is a lot like this, but it's on a smaller scale, and it's on the way that it's mounted. And we'll see how that works as we go through looking at all this. I'm just going to show you guys a couple of examples here. So I want you guys to see something that's out of specification. There's a centering. As you can see, the centering's vastly off on that. Okay? Okay, the way the centering works on this, and this is why I grabbed this volumetric flask over here. This is the best way to describe it and show everybody how it works. The assembly here, along with the shaft, this is going to represent it. It's sitting up against the plate up here. So this is how this is. So this assembly up here sits up here, and that's holding the shaft down here. So in order to change the pitch of that shaft, depends on how I have to. These three screws right here, the three big screws, hold it up against the metal. So that can't change nothing. Those coming up, they can. If you over tighten these a little bit, you can get a little bit of play in it, very minute amount of play, but nothing major. That's not going to really change the pitch too much. The way you change the pitch is the smaller screws. You drive them downwards, and what they do is if you drive them downwards, you can change the pitch by changing which way it goes. So there's three of these little set screws here. So in order, depending on which way you want to drive it, you drive it downward. This is what changes the pitch, and that's how it changes this right here. So again, if I want to drive it that way, I'm going to set this little screw right here, I'm going to sit and drive that one downward. Or if it's already down and I need it to come back this way, and it's already down on this side, I'm going to loosen it up so that it brings it back this way. Because you can't do nothing about the three of these. The three of these are bringing it up. It can't go up any higher than the metal it's up against. But you can definitely drive it downward and change the pitch of it by driving it downward. And that's the best way to describe how this works. So in order to adjust it, first and foremost, we need to figure out where the deflection is at. So let's just take it right here. We'll start off on this side over here. Looks like that's probably right around where it needs to go. So on this side here, I need to go that way with it. The only way I'm going to change the pitch is by taking the shaft and pushing the shaft that way, correct? Everybody can see that? So the only way I'm going to be able to do that is taking a look at it. Now I drove that one down. That's how I got it to do this. So obviously this one here, since it's down, and you can look at it right there, needs to come back up. So you'd have to release the two big ones on that side to allow that. I can leave this one in place. I can loosen those two up. And I can simply look at this and back off or drive downward the one that I need, and it changes the action. So now that's off. I saw that loosened it a little bit. Now it's back in an acceptable range.
Yeah, better than before.
He didn't tighten it all the screws yet. It's gonna be a little change. Right? Almost perfect.
Yeah, I try to get it as good as I can too, especially if I usually will accept a 0.5 or less. I'll accept that number, even though 1.0 passes. But we've had a lot of issues lately, like especially with the new lot of prednisone that's come out from USB. The tablet's good, but it's a lot more sensitive to things such as vibration, the deaeration techniques that everybody uses, and wobble. So I found more success on passing the chemical calibrator test by ensuring that the wobble is 0.5 or less. So again, the more you can adjust it, by all means, the more adjust it. But again, if you ever get lost on what you need to do, it's simply a matter of which way you want to push it. Take a volumetric, that's the best way to describe what you need to do. And whichever way you need to push the shaft. If I'm taking this right here and I see what the deflection is, and if I need to bring the shaft this way, so if I turn this around, if I need to bring the shaft this way, then what am I going to do? If I push this, that brings the shaft that way, so now I can see it. Because obviously if I push on this side, it's not. So now I know where I'm going to start at. It's not always the same thing. And sometimes you may get, this one was easy because I drove that one down. And there happens to be a set screw right there. Mm-hmm. Sometimes you get it to where it's in his area and it needs to go this way. But that's right in between two of them. So you may have to take both of these and adjust them slightly down, tighten it back up and see where you're at. And it's a constant play. The other thing I need to tell you guys to bear in mind is one last thing. We're checking the upper portion of it. Just because I adjusted the upper portion, I have it in line now, doesn't mean the bottom's still in line. So you need to check the bottom again also. Because you can adjust the upper one and have the lower one not be an adjustment. It can happen. Just because of the way the pitch is coming inside there. The way you adjust it is you're going to have to adjust and split the difference. If you have it perfect up on top and it's out of tolerance on the bottom, then you're going to have to bring the bottom back into tolerance. Maybe go to, let's say it's reading 1.5. Bring it down to where it's 0.75. And hopefully the upper one's at 0.75. You're probably going to have to split the difference.
Okay.
Because again, all that means is that the pitch is different. So again, the pitch right here might be fine. The pitch down here has a lot more play in it. So the centering's not exactly right. So you're going to have to play with it.
From dot to line, that means it's half a millimeter, 0.25.
Yes. From dot to line is 0.5, so we cut it in half, it's 0.25. And you can't measure anything lower than that, so. Any questions on that, on the